Okay, today, in this tutorial, we're going to do a couple things. First of all, Unity has a library, a API called ML Agents, and that is an API that uses Python. In particular, it uses TensorFlow library of Python, and it also uses C#, of course, because it's Unity. And so then there's communication between these two. So what we'll actually have is a Unity SDK communicating with a set of ML algorithms that'll be running in Python. So our goals for this tutorial are to get Anaconda and Python 3 and TensorFlow working so that we can run AI using things like neural nets that TensorFlow makes easier, and we want to get ML agents from a Unity GitHub repo, and then set up an environment for ML agents. And finally, I want to show how you might start modifying some of the ML agents examples after we get it running. Okay, so first thing we want to do is go to Anaconda downloads. So this is the website for Windows. They have a lot of different things, a lot of different downloads available, and you just want to download that and install with the so you want the Python 3.7 version, and just install with the default install settings. Okay, the next thing we want to do is go to Unity's ML Agents repo, which is right here. So that is a GitHub repo, and we want to clone that. So a couple ways of doing this. If you don't already have Git installed, you want to get Git from Git SCM, so download that. Once you've downloaded that with the default settings, you can open a Git bash shell, like so, by just typing into the Windows key Git bash. If you're on a Mac, you can just use this right out of the terminal, and you should, if you want to use GitHub's own desktop technology, which just makes using Git a little easier, go ahead and download this, and you can pull the repo from there. And finally, one last way of doing this, we can just download the zip and unzip it. Doesn't really matter which way we do that. So I prefer using Git from the command line. I've got Git installed, and the procedure now is to open a Git bash shell, and we're going to cd to the location where we want it. So let's just put this in downloads, and git clone, and then the repo link that I grabbed from Unity's repo here. Okay. So that's going to take, oh no, that's something else. that's going to probably take a little while, but that is the procedure. Let me actually close some things here. Okay. While that's happening, if we look at the repo, these are the things that we'll get, and in the README there is a good description of it, and then documentation home is where we want to go. And for Windows, if we go to installation, there are directions for Windows and Mac users. So here's the window guide. I've found that I actually don't need to change my environment variables every time I do this install, but if you do, there's some very good directions about how to do that. You pull up your environment variables for your system by just typing environment into Windows, and you can just start editing the system variables by going right there. So you can see I have some things added here for Conda that they specify here. I won't go through that. I think they're very clear directions. You basically just add these into your path under system variables. So I'll just show you where that is real quick. So here's my path. If I click on that, those are my user variables, sorry, and then path for system variables is going to be here. Thought I just saw it. Right here. Okay. So that's where that stuff can be found. I've actually tried to do it without changing your system variables because Anaconda by default should modify those. After that, you want to go to your command prompt. You should now be able to type Conda and see something like that. We want a Conda create -n ml agents Python equals 3.6. And what this is doing, so Anaconda when it's installed is, if you get everything, is a big set of Python APIs where we can install specific environments that don't affect our entire system. So Anaconda Navigator, oops, sorry about that. Anaconda Navigator itself looks like this. Make it a bit smaller here. And you can see we can open things like Jupyter Notebook, VS Code, so lots of cool stuff. The other thing we get when we install Anaconda is we get this ability to type Conda commands into our command line, and that's the thing that you might need to modify your path with. So what this is doing is it's creating an environment called ML Agents that's going to be running Python 3.6. So we could change this to like 2.7 and it would run 2.7, and so in this way we can install packages into this environment, install libraries into this environment, ML agents, and not have them affect our entire system. So it's very useful for Python libraries because those are usually, all the packages are usually all over the place. So in terms of versions and stuff like that. So go ahead and run that. I've already run that. And after that you want to activate, Conda activate ML agents, like so. And you'll see your command prompt changes. That means that we're just in the ML agents environment. Once you've done that, cd to wherever you put your Git repo. So mine's in downloads. We can look at that by typing ls, or you might have to type dir. I have a Linux environment set up on my Windows, so I can type Linux commands. So somewhere in here, there it is, ML agents is what we want. So let's cd to that. Turn my volume down so I don't break everyone's ears every time that happens. So we're going to cd to ML agents. Once we're there, if we take a look at these directions, we want to install TensorFlow. So we'll run that command right there. And that, again, this is a specific version of TensorFlow that works with ML agents currently, and it's only going to install to this environment that's now active ML agents. Okay. I've already, actually, I'm not sure I have. Yes, I have. I've already run that for my ML agents environment, so I'm not going to run it again. And now we want to run pip install. So by having Python 3, we also, in the Anaconda distribution, we also have pip. So we're going to run pip install, and this is just Python package manager, ML agents. And that's going to go and get all the libraries we need to run ML agents here. That's all we need to do on the Python side. We are now ready to run a program. So on the Unity side, I'm going to get Unity. So if you don't have Unity Hub already, make sure you get it. This is very, very useful. As you can see, you can install different versions of Unity, which is very useful. So I've had more luck with ML agents with the 2018 versions, but they actually do run with 2019 too. So I'm going to run with 2019, which is the latest stable version at this time, I believe. But you can install multiple versions, and then when you open your project, you can pick a version and a platform right here, right? Whoops. Didn't mean to do that. Actually want that for that. Okay. Yeah. So let's see. Let's add its project that we just got in downloads called ML Agents. And we want to go to the Unity SDK. That's the actual project. Alright. So we just added that. Let's go ahead and open it. It's going to update everything. That's okay. Alright. So while that's opening, and it's going to take a little while, I just want to go over what the folders we have here in the Python files and how they interact with the C# files. So if I go to my downloads and I go to ML agents, see we have a lot of stuff here, right? So we have a Unity SDK, and this is where all of our ML agents examples are that we're going to mess with. So there they are. That's all in the Unity SDK along with some other stuff. Now everything else in here pretty much is Python scripts that communicate with Unity. So if we go to agents environments, for example, we can see things like communicator.py. So one of the things that helps Python communicate with ML agents. Ooh. Get rid of that. Okay. So here we have some Python code. I'm looking at it in visual code right now. And so this is a communicator, base class. And it's going to specify things like the port that's going to be used to communicate with Windows. You can look at the environment here. And so again, this is all Python file, and here we're using NumPy, so a data science library for Python. These are just some of the ML agents files. If we want to look at the actual brain.py, so how things get processed, we are again using NumPy, and here we're dealing with things like the actual rewards for these vectors that will pass from Unity into these brains so that they can learn over time. So they're passed vectors, and the vectors are going to learn according to a couple algorithms. Alright, so that's just a brief tour of what's going on in all this all this Python code, and that was just ML Agents environment, ML Agents itself. Let's check out the README. I bet they have fairly good READMEs here. Yeah, okay. So here's how to actually install, like we just did, and a direction to their code. Here are the trainers. So here's where it looks like they're actually communicating. They're actually running TensorFlow. Let's take a look at their models. Yep, so here they're importing TensorFlow. They'll probably get the vectors from Unity at some point. Yep, here's the vector. And then they're setting up a model. And models are going to be the things that actually learn and then pass that information to Unity in a .nn file, which we'll access as the brain. All right. So that's all that. Let's take a look at what's going on in Unity. Here we go. This is what ML Agents actually looks like. So if we take a look in examples, let me bring this so you can actually see it. And I'll leave Maximize on Play on for now. So if we take a look in examples here, 3D balls probably the easiest to understand. So let's open 3D ball as a script, and if we let's just try and run it right away. So that's what it looks like untrained, and the idea is that these platforms can learn to balance these balls perfectly by just trial and error and rewarding times when they keep the ball balanced over time with certain actions. So in this script we have a 3D Ball Academy, and that 3D Ball Academy has training configuration and inference configuration, and here we have a link to a brain. 3D Ball Learning Brain here is not functioning, so they're dropping the balls because it's missing its model that TensorFlow would normally generate. That's okay, because we're going to teach it a model right now. So once again, this is what it looks like untrained. So what we're going to do is here in our downloads.ml agents, we are going to run the training command. So let's take a look at what that training command looks like. So here I am on the basic guide. Let me show you how to get to this. So if we go back to the root directory of ML Agents on GitHub, and we go to their documentation home, and then we go to basic guide, which follows right after installation, that's where I'm at. So if I scroll down here, eventually I will get to the command to run ML Agents. So run identifier, here's the actual commands. Here's our configuration, which is going to be how we're talking to TensorFlow, and that path has to be there. So I'm just going to paste that in here. So what we have is ML Agents -learn config trainer YAML first run, and let me make this a bit bigger so you can see --train. So I'm going to give this a better name. This will be what our ID gets stored. So let's do first train ball --train, and when we hit enter, it's going to prompt us to start the Unity editor. So if we go over, now we have a port open that can talk to the Unity editor, and if we go to our Academy here and we select control, this is a very important step. Select, it won't work otherwise. So check control, that's going to let Unity know that we want to actually train it, and then hit play. What we're going to see here in just a second if all goes well. Let's see what's going on here. What we're going to see here is Unity getting frozen. An item with the same keys already made key, platform, 3D ball, okay. Well, that's interesting. Alright, so looks like we get a crash here. So what do you do when you have a crash? Let's hit Control C to, oh, it is in fact running. It was just paused. I forgot I can do that. So if you click in your command line editor, you can actually pause things, at least the way mine is set up. And then if you hit enter, you can return to running. So, sorry about that. There wasn't a crash, that was user error on my part. So here, what we're looking at right here is epochs. So many very quickly random actions that have rewards when the ball bounces for longer on each of these platforms is happening. And that's getting fed into a neural net in TensorFlow that's learning the same way the human brain, kind of the same way the human brain works, how to maximize the amount of time that a ball is balanced by making better and better movements. So we penalize it when the ball falls off, and we reward when the ball stays on. And eventually, these, as you can see, are starting to get better at balancing the ball. So they're not great yet, and we can take a look at what's going on here. So what this is saying is we've run it 3,000 times. We want to see our reward going up. That means the ball's staying longer. We want, yeah, so that's happening, and the standard deviation of the reward is also going up, so that is good. Alright, so at some point we can either stop it here, or we can go over to our command line that's running. Oh, and there's some nice information about the types of steps and memory and all this stuff that's happening. So if I hit Control C here, it's going to stop, and you could also have just stopped that in the editor. It doesn't matter which way you do it. So here's what happens when you stop. It's going to generate a graph which is going to contain the weights of the neural net that learned in TensorFlow, or whatever algorithm they're using for 3D ball learning. And here, so in models, first trainer ball, 3D ball, NN, we have a NN file. So once again, if we go to our academy and we switch control off and we run the program, you'll see that it's not yet trained because it doesn't know where its brain is. Okay, so let's follow the path back. So we have this 3D ball learning, which is missing an NN model. So let's go find that. And that's exactly what it's telling us is right here. That got generated, that got exported at the end of this training. So if we go to, let me just pull up my documents here, our downloads, ML agents, models, and there's our first whole model, and we get a whole folder there. Let me make this smaller, and we're just going to drag this over into Unity. Okay, so we pull up Unity, pull up my documents again, and see how we have a TF models folder here? Let's just drag it into there. Okay, so now if we look at our TF models folder, oops, it didn't go in there for some reason. Let's do that again. Unity, documents. Alright, so 3D ball learning. Oh, it did. It's just called that. Alright, so we have this 3D ball learning 1. And now if we go to the academy and we put this 3D ball learning model, oops, we go to the brain, sorry, and see how it's still missing a model. If we go to TF models and we pull, these are the same file, but we pull one of these into here. Now if we run it, you'll see that we have trained agents. They're still not perfect. right? But if we let it run longer, they would become smarter at balancing this ball. Okay, so that's pretty cool. There are a lot of examples of using TensorFlow and all kinds of ML libraries in here. One thing I want to go over real quick is like if you wanted to modify some of these into playable games, it is possible to do that, and let me just show you real quick like some basic ideas to get you started. See, to dive into this code. So let's go to Bouncer, Scenes, Bouncer IL. I'm not going to save that. And if we take a look here at the Bouncer game, if we just run it, what we have here is it's actually pulling my input. Nothing's happening yet. But if we hook up, so if we go to our academy, we switch control off, and we train. So let's save, and here let's activate this again, but let's call this first train Bouncer this time, so that'll be the name of the folder that gets generated. If we run that, and we start training, okay, so it is trying to learn. And did I pause it by accident? Oh, we might need to actually hook up the brains here. Alright, so let's kill this. Control C. And let's go to our academy, and let's take a look at our Bouncer learner. So we're missing an NN model. Let's see what models we have here. We have Bouncer learner. We can just throw that into there. And for our teacher, let's see here. Bouncer player has, oops, if we go to TF model, Bouncer player doesn't actually need a brain because that is going to be us. Okay, so our student now should have, if we go to our agent body, Bouncer learner has a TF model. Alright, and our academy has control on. So now if we run this, we train, we want first train Bouncer to be the thing that we're looking for. We run this. So in this game, what's happening is the ball, the cube is trying to bounce into the banana, and it's learning how to do that with better and worse sophistication, and it's trying to bounce into the banana without falling off. So there's some physics going on here. This is actually pulling my input. So as I move the arrow keys around, it's generating, but it's all happening so very fast that what's really happening is it's learning on its own, and every now and then learning from me when I do the right kind of thing. So, all right, that's enough time for it to learn. Let's kill this, and let's go look for that new brain. So I'm gonna grab that, and that's going to be in models, first train Bouncer, Bouncer learner NN. So let's drag that into there. There's our new brain. And for our academy now, for our Bouncer, if we go to our brains actually, and we want Bouncer learner, and this is going to have Bouncer learner 1 now as a brain. Okay, so now if we play, you'll see we already have kind of a two-person game here. Oh, we have to turn control off. So academy, let's turn control off, and let's run it. We already have a two-person game here. So you see it's not great at getting the banana, but it is kind of trying to. And over here, I can move around with the arrow keys or the WASD keys and get the banana too. So it's kind of a two-player game. We could set up a simple scoring system here. So let's do that. And it's just to show you, you know, how to modify. Whoops. That's not it. How to modify. You know, so we've done all this, and I just want to show you how to modify some of these ML examples, so you have an idea of like what's going on in the code and how you might just start to modify things. I won't talk about how to modify the actual hyperparameters on the Python side, but just to give you an idea of how to start understanding this code, let's add a UI element. Let's add some text. In fact, let's add two. And let's to the main camera. Let's make sure those are showing up first. Yeah, there they are. Alright, and then canvas, let's add a vertical layout group. And we won't force expand height. Let's see what that looks like. Okay, there's our text. So let's just make a simple scoring system here. And this can be player score, AI score. Doesn't really matter what we call them. And for the actual text, let's just start with 0. Well, about player score 0. AI score 0. Okay. And then, so we have 3 scripts in this, the bouncer and the agent in the academy. If we take a look at the agent. Oh, this is new and frustrating to Visual Studio. So something I've noticed about Visual Studio with the latest version of Unity, you have to actually open Visual Studio from there and then open the solution in order to get Unity to recognize its own libraries through Visual Studio. I don't know, I mean, this might be something specific to the way I have things set up, but that is what I've found. So no big deal, we just have to open the solution here. Once that's open, we can start taking a look at these scripts. So let's load that in. And so here's the bouncer script, and you can see what's happening is here's our vectors that we are adding rewards to and then sending to Python as things happen, right? And then sending to our TensorFlow library as a vector. So this all actually happens if we can see this all happens when, well, it happens a lot of the time, but when in particular we have a collision with that banana, we are adding a reward here. And so let's just go ahead and make 2. Well, first let's import using Unity. Engine.ui, and let's have a text box called scoreText, and let's have a int called score, and when we wake up, let's set score to 0, and then when we add the reward, let's also say scoreText dot text equals score plus I'm not using Python score plus, whoops, score dot toString, and we'll just bump up score right before we do that. Okay, score plus score dot, cool. And then, so each of these have a, what's going on there? Each of these have a reference, so you know, we could make these more specific, but that's okay for now. So it's in our banana script, and it just needs, this is our player, it just needs a reference now to player score, and our AI banana needs a reference to AI score. And then let's save it and run it. And as you can see, so I'm not going to do anything for a bit. Here's the AI. So its score will start bumping up slowly when it finds that banana. It's not super good at this yet, but we could run training as many times as we want to make it really good. Alright, I'm tired of waiting. I'm going to start moving around, and you can see my score is going up right here. The AI is not doing so well, but it's trying. There we go. So it's got 2 on the table. So there's the beginning of like a nice 2-player game with some machine learning involved. And to see what's going on with the actual machine learning components, it's worth taking a look at exactly the things that we are sending when we, in our agent actions, you know, that we are recording and then collecting as observations, so that we can use to generate these TensorFlow models. Okay, so I hope that was enough to at least get you started running some of these examples. Take a look at the code in there. Take a look at all the Python code going on in here, in particular in in ML agents and ML agents environments. That's where most of the action's happening. And yeah, I hope that was enough to get you started. Unity's ML agents is a very, very exciting API and SDK, and I'm just stoked that this is being developed still, and I think there's a lot of possibilities for with this physics engine and the TensorFlow possibilities for a lot of cool AI simulations that can be, you know, endlessly complex or simple as you want. So happy coding and happy creative thought with this kind of cool setup. That's all.